What causes time-consuming debugging for algorithm errors? Imagine trying to fix a puzzle where some pieces seem to fit, but the picture still doesn't look right. Debugging algorithms can feel just like that. When errors happen in how an algorithm is implemented, it can take a long time to find out why. Unlike syntax errors, which are caught quickly by the computer, logical errors are sneaky. They make the program run, but give wrong results. That's what makes them so tricky and time-consuming to fix. One big reason is how complex algorithms can be. They often work with many parts that interact and change over time. The number of possible states or input combinations can grow very fast. Sometimes bugs only show up under very specific conditions, which are hard to recreate. Finding that exact input or sequence that causes the problem can take a lot of trial and error. Another cause is incorrect algorithm implementation. When translating an idea into code, mistakes happen. These can be off by one errors, wrong loop conditions, or faulty logic branches. Since the code runs without syntax errors, the problem isn't obvious. You have to carefully trace each step and compare it to the original plan. That takes time and patience. Our mental models also play a role. Debugging requires imagining how the algorithm and system behave. But software states change constantly, and our mental picture can be incomplete or inaccurate. If we misunderstand how parts of the program work, we might waste time testing the wrong things or chasing false leads. Legacy code and technical debt add to the challenge. When algorithms are buried in old or large code bases, understanding the original intent can be difficult. Outdated documentation or workarounds can obscure what the code is supposed to do. That makes pinpointing errors more complicated and slow. Testing is another factor. If tests don't cover all possible inputs or edge cases, errors can hide until late. When bugs only appear under rare conditions, it takes longer to find and fix them. Without thorough testing, you might spend hours or days trying to reproduce the problem. Psychological factors also matter. Debugging can be frustrating, especially if errors come and go or are intermittent. This mental fatigue can slow down your problem solving and extend the debugging process. To make debugging faster, it helps to plan your algorithms carefully before coding. Writing good automated tests that include edge cases can catch errors early. Using debugging tools to step through code and watch how variables change is also very helpful. Breaking down complex algorithms into smaller parts makes it easier to test and find mistakes. Working with colleagues through code reviews or pair programming can catch errors sooner. Keeping your code clear and reducing technical debt helps you understand the logic better and find bugs faster. Understanding why algorithm errors take so long to fix is the first step. Applying these practical strategies can help you troubleshoot more efficiently, saving time and effort in the long run.